Hey everyone, today we are solving early access on HackTheBox, a hard-rated Linux machine. I do have COVID at the moment, so just please ignore that. Right off the bat, we can see we have a Rust scan here, and we have a few ports open for TCP. We have 22 for SSH, 80 for HTTP, and 443 for HTTPS. In addition to that, we've also run a UDP scan. This hasn't found too much, but the same sort of ports as well. Cool, so let's move on. So we'll go ahead and check out the more detailed port information. We have 22 open, very standard stuff as you'd expect. 80 open, again, very standard stuff. We have Apache running down here, but we'll do more enumeration on that in a second. And then 443, the same sort of thing. Okay, interesting. We have a few email addresses here that have been leaked inside the SSL certificate as well. That might be useful for later. Cool, so let's move on. So here, I'm going to go ahead and run whatweb. Whatweb will basically tell me what's running on the web server in terms of technologies and that kind of thing. We can see here we have, say, Apache, Debian, we have a HTTPS site and a HTTP site, and that kind of thing, but not that much interesting stuff. We also have an email as well. Cool, let's go ahead and run GoBuster. In addition to my GoBuster, I'm also going to append the extension of PHP, since this is Apache, so I'll go ahead and add in the PHP there. We'll now go ahead and look at the web application. I've added this into my Etsy host, so if I go to cat Etsy hosts, you'll see here right at the very bottom we have an early access. And I also have some other subdomains that we'll come across later, just so I don't have to spend time adding them in there. But let's focus on this one for the moment. Okay, cool. So we'll go ahead and check out the web application. Go ahead and accept all this kind of stuff. Cool. So we got a ban here. This is because basically our GoBuster has triggered some malicious traffic and it's basically banned us. It's now been a minute, so we'll go ahead and check out the web application. Cool. Should be now able to view it. Indeed we can. Okay, so we have a Mamba page and an early access available now, with a registry function and a login function. Let's go ahead and check that my Burp Suite is listening, so we can go ahead and just add this into our target history. We have here, I'm going to go ahead and make sure, yeah, this is already in my scope. Cool, fine. So now whenever we go through here, it's now going to populate. Okay, so if I just scroll down here, nothing much interesting. A cool snake. Yeah, okay, fine. I'll go ahead and now create an account. I'll go ahead and use, say, sub. My email, password is the same, and there we go, cool. Let's go ahead and now register. Cool, that looks like it's now worked. So we can see our name reflected here. Interesting. Let's go ahead and click around. Okay, cool. We have a bug scoreboard showing errors, game key not working, game is unoptimized, bug game is crashing. Interesting. So we have a bit of information here. We'll come back to that later though. Interesting. We'll go ahead and check out this one. Interesting. Just having a quick view really as to what there is. Interesting. So we're having some information regarding basically a game that is unoptimized, but we haven't got there yet. We have information regarding a game key not working, and in addition, a fallback implementation being made for manual verification. Again, we'll come over to that later. And then further, we'll have like a scoreboard showing errors. This here, I found a critical bug in the game scoreboard. My username returns to strange errors in the scoreboard. Please fix this issue. Thanks, single quote man. This points towards SQL injection, but we can't really tell till we can actually go ahead and try it. Let's go ahead and check this out. So can we change our name? Okay, well, there's a profile functionality, and there is a name change functionality. Okay, interesting. So for the sake of just trying, I'm going to go ahead and put a single tick here real quick, just to see what happens. So they said that they had an error when they had a single quote in their name. Well, I can't see any scoreboard here for this to reflect. But nonetheless, we'll at least have a little look around while our name is how it is. We can see here there's a messaging functionality. Now, it's important when you do web testing to enumerate basically all the functionality aspects and where your name or input or any stored data or anything like that is reflected back to you. In this case, we can see here there's an admin at earlyaccess.htb. I'm going to go ahead and just spam them a message and go ahead and see what happens. Message to admin has been sent successfully. It may take a few minutes for the admin to read it. Okay, interesting. So this points to me that there's going to be some kind of admin user that's going to read our content. Interesting. And there's previously mentioned in the forum that a single quote was basically killing some stuff. This might imply that this application is a little bit of a more development end. There's some bits in here, and it's worth obviously enumerating that. So let's go ahead and try some more stuff. So this didn't throw any errors, but that's because we want a current scoreboard. Go ahead and try adding in, I don't know, like a header, for example. So a header test. Go ahead and hit save. We'll go ahead and now see if that's reflected anywhere. So our name isn't reflected anywhere here, it's reflected there, and that looks to be the only place that it's reflected. However, if we go over to messaging and message inbox, we can see here that our name is actually indeed reflected if we go ahead and make a message. If I go ahead and now make a new message here, we'll actually see that our name is then reflected. We'll go ahead and look at this one. We can see here test. Now it's kind of hard to tell if this really worked or not, since this could actually be the default configuration of the application. So let's go ahead and try something a little bit more obvious. We'll go ahead and just marquee it. Marquee is useful because it's obvious if it's working, because our text will be flying across the page, and it's far more likely that this actually is going to give us what we're after. We'll go ahead and look into the outbox, go ahead and click this one, I think, and then we can see here that test is flying across the page. So that tells us we have HTML injection or XSS. Now we have HTML injection, I want to go ahead and test if we have JavaScript injection. I can simply do this by doing, say, image source equals x, which will basically create an error, then use the onError event handler to then run some JavaScript. In this case, I want to go ahead and run alert1, like so. Go ahead and copy this just so I have it in my clipboard. Go ahead and just pop it down here. Cool. Now go ahead and make a message to the admin. We'll now see that if I go ahead and type in, say, XSS, when I go ahead and view the message I sent to the admin, the alert box will pop up, and that proves we have JavaScript injection or XSS. So what we want to go ahead and do now is we want to go ahead and use this to do session hijacking. Now when I say session hijacking, what I mean basically is that in your browser, you will have what are called cookies, and these cookies can sometimes be obtainable via the browser or by your JavaScript. In order to get this, for example, in my console, I can type in document.cookie. What this will do now is it will basically go ahead and pull down the document.cookie value and then print it out to me. In the same way, I want to go ahead and basically make it alert this document.cookie. So if I go ahead and type in alert document.cookie, go ahead and type in enter, it will now then alert me the same information. Basically meaning JavaScript can access my cookie and therefore I can then steal someone else's. So how do I do this? Well, what I want to go and do is I want to go ahead and use basically an image source and error it, so then I can then execute some JavaScript and then refer to an external image. This will basically allow me to include variables, JavaScript variables, to pull in there. It'll make a little bit more sense in a second. Let's go ahead and try this. So what I want to go and do is I want to go ahead and set up a web server. So I'm going to go ahead and type in lweb here. Because here we have web server listing on 10, 10, 14, free at 9,000. Doesn't matter about this part here. Paste that here. What this will do, basically, is create an image source that doesn't exist. The onError event handler will then pick it up, and then it will then create a new image element on the page using JavaScript. And what we can do then is we can then use the document.cookie variable that JavaScript can access, and then include that in the URL to our image source. What this will mean, basically, is it will then make a request to our host on this IP and this port, including the document.cookie value, and then we can go ahead and steal it. Go ahead and hit save. Go ahead and open up a web server, like so. Check this all looks okay. Yep, looks fine to me. We'll go ahead now and make a message. Contact us. And I'm going to do XSS, hit send. So here we had some requests made by the 10.10.11.110 host. What this means basically is that the admin has executed our XSS and is now making a request to us for that image source we referenced. However, unfortunately, it's having some SSL bits, basically meaning that we can't see the data since our web server is on HTTP and not HTTPS. Therefore, we need to escalate our web server to be HTTPS so we can actually read this SSL data. We can go to this URL here that will basically give us the code required to create a HTTPS web server in Python. In this case, I want to use the Python 3 version, and I will use my own code that's basically the same as that. The only difference is I have just put in my IP here, and just adjusted the pathings of these to be not path and just using basically my IP. Cool, so that should be fine, but we need to go ahead and create these here, so we'll go ahead and just use the command they used. Cool, go ahead and hit save. That one I run, sec aura for the password, and sec aura for the password again. Cool, we'll just spam through this. Cool, that should be okay now. What we'll now go ahead and do is I'll go ahead and run this, Python 3, SSL snake, sec aura, invalid argument, sec aura. Cool, that's now working. I just typed in the password wrong basically. We need to go ahead and adjust our payload in our username to now be HTTPS like that. 44443. And hit save. That should be okay. Cool. We'll hit save on that. We'll go ahead and then, yeah, this is listening. Cool. Fine. Now we'll go ahead and make a contact us. Go ahead and do XSS, hit send. And we wait a few seconds and we should then have a request come through. Here we can see a request has come through from the 10.10.11 host, and we can see here there's a bunch of stuff in here. I want to go ahead and take this out here, so we'll go ahead and grab this just to make it a bit easier to read. Go ahead and open a new file here, go ahead and hit this here. And just so we can read it a little bit easier, I'll go ahead and just do Control-H. And I'm going to go ahead and replace the semicolon with a new line. What that will do basically is it will just give us the separation between the early access token and the other token. Cool, that looks fine to me. We'll go ahead and just check that that's okay. Yep, grabbed that and grabbed that. Fine, cool. All right, now what we'll go ahead and do is we'll go into home. We'll go ahead and go insert element, go to storage. We'll now go ahead and just replace our token with their token. You see the %d is at the end of, not that one, sorry, this one. See the %d is at the end, so if we go ahead and just hit paste, hit enter, go ahead and now hit refresh, we should now be the admin, and indeed we are. Sweet. So let's have a look around the application. So we have messaging that we previously used, we have an admin, we have a dev, and we have a game. Okay, so we don't seem to have access to these directly. We need the password for admin here, and we need an email and password to access game. We'll leave that for the moment since we don't have any access to that. Cool. So let's go ahead and check out the admin panel. Go ahead and it should give me something. Oh, nothing. Cool. So here we have the admin panel. Nothing there. Basically the number of users. User management, under construction still. There's a backup functionality, and there's a verify game key. Interesting. So let's go ahead and read this. So it says here, since the API has been down a lot lately, we have come up with a temporary solution. As requested, an offline backup game key validator algorithm is now available to all administrative users. To use this, the magic number must be entered into the validator application. So let's go ahead and download it. We'll go ahead and hit save. Shall I go ahead and just open it here? That way I can go ahead and save it more easier. Open with code. Extract to early access, and then we'll go ahead and just call this one code, since there's a bit to this part. Cool, so that should now be in there. Fine. So let's go ahead and take a look at the code. So we should now have a directory. We'll go ahead and actually just close this down and open it up via here. Cool, go to ... code. Fine. So we should now have a directory called code, and we should in there have a validate.py. So we have quite a lot going on here. So we need to go ahead now and deconstruct it all and figure out what's going on. We'll go ahead and run this. So this is in this directory, so we need to go ahead and cd into code. We'll go ahead and do python free validate. It tells us we need a key. Let's go ahead and take the key. So this key was previously mentioned on the web application, that basically we need to offline validate it. So in this case, we provided a key, and it hasn't worked. And you'd expect that, to be fair, since of course, you know, the key isn't a valid key, and it's not going to give us a working key. So we need to go ahead and basically figure out how to reverse engineer this Python code and step through it and figure out how it all works, okay? Let's go ahead and just kill this so we can get to it a little bit easier. Let's save all, whatever. Fine. I want to get rid of this. And save, cool. All right, so let's go ahead and run this through. So we'll start from the bottom since that's where the entry point is. This here checks if basically if we provided a key. If we haven't, then it errors out basically. Then we have a validator, which basically takes our input, so basically the key we provided, as in this, passes that into the key class, and basically creates a key. And then we then use the, and then we sign that to validator, and then we then call the validator check function. So let's go ahead and basically step through that. So when we provide a key like this key is instantiated with this here basically. Things set like the magic value and the number, they'll come into play later. And then the check is then called. So the .check method is called, which is here. So basically we have to go through these bits here. So first of all, we have to check that it's a valid format. So we'll go ahead and sort that bit out first. So let's go ahead and basically grab this here. We'll grab it all properly. Cool. We'll go ahead and open up regex 101 on the page. Cool. I'll go ahead and basically just bung that into it and just basically check what a valid key looks like, just so we can get an idea. So what this will do basically is it will run our regex against string here. So this matches. So if I remove this here, we're going to get, that's going to work, but it's not going to work fully from the looks of things. Actually, the reason this is working is because we need to remove these capture groups around the regex. Basically, it's taking these as separate instances rather than a whole one. There we go, cool. If I now remove the 4, it should then not work, but it seems to be working anyway. Maybe it's Python. Yep, that shouldn't work, but it is for some reason. I'm not sure. But if we go ahead and maybe remove bits, yeah, there we go. So 1, 2, 3, 4, and it's okay with that. Cool, so now we know how that kind of works. Basically, it's just checking that our key fits the validation. We move on to the next bit, okay? So we've done the valid format. Let's look onto the G1. G1 is part of the 5 many challenges we must solve. So first of all, let's look at G1. The G1, basically, it looks kind of complicated, but really it's quite simple when you untangle it all. What it would do basically is line 35 will basically split up the key on every hyphen, so basically making it so this is like a list now, like that. And then we take the 0th index, which is basically the A's. So we'll now go ahead and add a little note in there saying basically hashtag, and then we'll go A. So we know that basically it's the 0th index, right? The next line will then work on that. Now this looks a little bit complicated. You don't have to understand so much what's going on under the hood as to what the Python functions are doing. And this is using list comprehension, so it's a little bit hard to read. But basically, you read right to left in this sense. So you read this bit first, and then you then read this bit. So for every iteration of this for loop, we then act this ORD on that iteration. So you can see here we have I and V, and you can see here I and V is then being referenced. Basically, what this is doing is it's taking the enumerator generator from here, and the I is the count and the V is the value. So basically in this case we're taking the value, so it will be its letter value, converting it into its integer value, bit shifting it left by the value of I, so basically 0, 1 or whatever, plus 1. You don't need to understand so much as to why, but just understand as how to bypass it effectively, and then we're then modding it. So the way I got around this basically is I just go ahead and create a new file. We'll call it g1 pwn.py. What this will do basically is I'll go ahead and put this over here. We want to go ahead and basically take this function and then just try and figure out how we can brute force it effectively. Let me go ahead and smooth it over here. So a few things we need to adjust, things that aren't that important. For example, we don't need to use self key. We can actually just say g1 is equal to this, like that. Fine. And then what we can do is, and then we can remove this bit down here basically. We can just comment this out because we don't need it. And then we can then basically say if it isn't equal to this, return false, but really what we care about is if it is equal to this, then basically print true. That will then give us as to what we're after, right? Okay, so that should now be okay, cool. So now, how do we actually brute force this, okay? So I'm just gonna go ahead and move this out of the way, just so you can focus your eyes on it a little bit easier. Actually, I'll just do this, cool. So basically what we want to go do is we want to basically figure out the combination of characters, for example, the first 3 characters. So the way this works basically is the enumerator is going to take the first 3 characters and basically check if when we pass them through this bit here, it equals this on the output. And if it does, it then returns true, basically. So the original code will basically check that if it doesn't, it returns false, but if it does, it will then return true. In our case, what we need to do is basically need to figure out the combination of the first 3 characters that will then return true. Now, looking as to how this works, we don't really need to actually do any of the maths behind it. We don't need to worry about this. We can actually just create basically a brute forcer that will basically do the work for us. I'll go ahead and just create a new file just to show you. So G1, we'll call it g1 gen.py, like so. I'll go ahead and just use this bit of code here. So what this will do basically is here's an alphabet, so A to Z basically. We'll then create a list with all these values in it, and then we'll then iterate through those. So you'll see if I now go to print G1, I go ahead and hit run. You'll see that basically it's going to print every combination of, ABC, ABB, ADD, ZZ, etc., etc. Basically every combination of a 3-letter word. We can then pass that into this and then basically brute force it from there. So what we can go ahead and do is we can basically just go ahead and take this. Actually, I'll keep that now. Copy. We'll go ahead and just basically replace the G1 with this. We'll go ahead and just plus this here. We'll go ahead and remove the G1. And then what we want to go ahead and do is we basically just want to pass this through here. And then if it is true, then I'm going to go ahead and basically just print G1. Go ahead and just have a quick read of that just to check that it all looks right. Looks okay to me. So we're going to go ahead and create basically we create an alphabet of A to Z basically. We then iterate through all the combinations of up to 3 characters long. We then assign that to G1 basically. So this will be G1, this will be G1 on each iteration. We then pass that into this list comprehension. And then if we then get this as our output after it's gone through this transition, we then get a true. Let's go ahead and hit run. And we get key. Cool. So the first 3 characters are key. And this last little bit of code here basically just checks that the last 2 digits, so for example, these last 2 is a number. So really it can be any number. So for example, it could be like this, A12, like that, or KY12. So basically the first bit is key 12, okay? We'll go ahead and basically just take that, we'll put it into our test. So key 12 will be okay. We know this works basically because it's saying, is it an integer, otherwise return false. Very simple. Let's now take a look at G2. So G2 is very much the same. We basically just take the second or the first element in the key, which is this basically, and then we will then go ahead and do some logic on it effectively. So I'll go ahead and just for notes like this. So B, basically, the second one. Let's go ahead and basically take this bit of code here and we'll create a new one. So we're going to group code, new folder, G2, just so it's a little bit cleaner. New file, g2.py. Cool. We'll go ahead and paste this in here. I'll go ahead and clean up a little bit. So this key can just basically be G2 equals, in this case, we'll just do B. Cool. And now we'll go ahead and basically just print the sum of this and see what this actually is doing. Let's go ahead and hit run. And we got a false. So I'm curious as to what this is doing, right? So I want to go ahead and basically, I'm going to go ahead and just make this A, B, C, D, E. And we'll go ahead and basically just print these out. So print P1 and print P2. Cool. Let's go ahead and now hit run. Okay, interesting. So we're getting for P1 is ACE, which is ACE. And then we're getting for P2, we're getting BD, which is basically this and this. Now we could actually calculate this by basically reading it. So actually what this is doing is it's taking the 0th element, it's taking the 2nd element and the 4th element, basically. Which basically just means if we do like P1, let's go ahead and space this out a little bit. So P1 is equal to this one, and this one. I can do the up arrow, right? Cool. And then the same for P2, except it's just offset by a little bit. Basically this one. Go ahead and put it like that. Yeah, cool. And basically P2 is equal to B and D, and P1 is equal to A, C, and E. Okay, so now we know how that works. We need to go ahead and figure out what this is doing. So this is saying P1 encode. Let's just take this sum bit here, basically, and see what it's doing, right? So we'll go ahead and do this sum byte. Cool. And then we'll do the same here. P2.encode. Cool. So let's see what it's doing, right? It seems to be giving us an integer equivalent. And what this basically does is it takes all the bytes in the string and it counts them all up, right? So if I go ahead and open up a Python interactive session, I think it's Python-I. Yeah, cool. I'm going to use Python 3 since that's the version of code they're using, just in case it messes anything up, right? If I now do ord, and then we take, say, the A, right? we then get 65, okay? If I then do, say, ord plus ord of, what was the next character? So it was C, like so, plus the ord of, I think it was D, A, B, C, no, I think it was E. We then get 201. And what do we get here? 201. Basically, it's taking the ASCII equivalent of these numbers, or the decimal equivalent of these of the characters, and adding them together. Very simple. So we basically need to check what it's doing. So this is basically saying if these two equal the same number, then return true. Okay, so we basically need to find a combination of numbers or letters that will then give us that value effectively. Let's use an ASCII table to figure out the maths behind this, okay? So we'll go ahead and open an ASCII table here. Cool. So basically we need the value of P2, so 2 values, to be equal to the value of 3 values when we add these together. So basically making 201 the same here. So we need to basically use low numbers for this element, and this element, and then higher numbers for this element and this element to balance it out, okay? So there are a few ways you can do this. There's no set exact way, but I'm going to go ahead and basically do the maths directly. So what I did basically is I looked to the ASCII table and I looked at basically the smallest number we can have, right? Now before we do that, let's just go ahead and check that we can actually have numbers in here. So for example, we could do like A1, 2, 3, 4. Okay, that's okay. That matches the ASCII, so we can use numbers. I just want to check basically. And also we can see here in the ASCII that we're allowed numbers, but not ASCII, the regex I mean. But it's just worth trying. Cool. So basically we can use any values A 0 to 1, A to Z, etc. So let's go ahead and review the table. So what is the smallest number we can use, basically? Looks to be 0, so basically 30, right? So we need to basically equal this number here. So we'll go ahead and try that. We'll go ahead and use 0 since it's the smallest number. Let's go ahead into here. We'll just basically go ahead and change this to be 0, this to be 0, and this to be 0. Okay, that gives us 144. Now, what is half of 144? That is 72. What is 72 in this case? It's a H, okay? Fine. Let's go ahead and now remove the last two. Go ahead and change this to a H. And that gives us 144. Let's go ahead and now basically take the value, so we'll call this A equals to this. And then we'll make this next one B equals that. And then we'll then say A equals B, and we get true. If I go ahead and modify B to be, say, J, go ahead and just move this out of the way. And this too. And then I now go ahead and do A equals B, we get false, because basically the values don't exist. If I now do A, we get 144. If I do that, we get 146. And I'll go ahead and make B equal to what it was before. Now A is that, and B is this. Now if we do A equals B, we get true. So that's basically how we do it. Based on this, our string can be O ho ho. So I'll go ahead and now change this to be O H0 H O. And then we'll now do this. We're going to now go ahead. See, this was false before. We'll now go ahead and run it, and we get true. And I'll go ahead and make this say a J or a K, whatever. You now get a false. So basically, our magic number is oh ho ho. We'll go ahead and save that now into our test.py. Like that. Cool. Oh ho ho. Right. Now we're on to stage 3. G3, here we have a developer note, add mechanism to sync magic number with API. Now, this G3 example is a little bit more complicated in the sense of this is using a variable that we don't really know. So the magic number, which is defined up here, basically is 346 in our static code, but in the live application, the live web app, it may not be. So we'll need to take that into consideration when it comes to later on. We'll go ahead and create a new folder here. Call it G3. We'll go ahead and add some code into G3, g3.py. We'll go ahead and just clean up a little bit. So we need to set a few things up here. So there should be a magic value. We'll go ahead and pull that out now. Magic value, magic number. Go ahead and just get these out of the way. Just clean it up a little bit, basically. Cool. G3 should be in here somewhere. Okay, I've named it G2 for some reason, just to annoy me. Cool. All right, we'll go ahead and add these in here. So that should now balance out to be correct. We should have all the values. This G2 needs to be basically some strings. We'll do A, B, C, D, E. Cool. And we'll go from there. Okay, so if the first two characters is equal to magic value, basically, so XP. Okay, so basically just means it's equal to XP. So we'll go ahead and basically make this XP like that. And then if it is equal to that, then we return the sum of the byte arrays of basically the magic number. This is very similar to what we did before. Basically, what it means is it's saying we want to count all the values up. So this basically, is this equal to the magic number? We'll find out. Go ahead and smooth the self out there. We'll go ahead and print. Cool. So we can now remove that out of the way. So that should now work in the sense of we can at least now run it. Let's go ahead and run it now. And we get a false. Okay, that's fine. That's expected. Let's do some debugging. So let's go ahead and take this here. Let's go ahead and print to the value of here. So we'll remove the equals, so we're no longer making it Boolean. We'll go ahead and hit run, and which it's 372. This value needs to be 346, right? If I now go ahead and say change this to be 372, like so, and go ahead and hit run, we now get a true, because basically the magic number is equal to the total value of these values. Go ahead and hit run, and that gives us that. So now we basically need to find a combination of characters that will give us the magic value, effectively. So we're going to go ahead and use what we used in G1, which allowed us to effectively create a brute force. We don't necessarily need this because we can use logic, but for the sake of automation, it's important to have. So we'll go ahead and copy that into G3 and just make sure that we're having it separated so we can tell what is what. So basically this is our generator here. So let's go ahead and just check real quick what it should look like in the regex. So in the regex we have it here. So it's asking for 4 characters and a number. So basically this one here needs to be A1. If I then make it A, it's not going to work. If I make it A, that isn't going to work. If I make it like a number, it's okay. So basically it needs to be 4 characters and a number. Now the first 2 characters are XP, so it needs to only be AAA or whatever. So 2 characters basically. We'll go ahead and add that into our permutations to be 2. Now go ahead and make this G3 like so. We'll now go ahead and just move this out of the way. And just adjust this to be what it needs to be. So G3 needs to be basically replaced. So it'd be G3 equals XP plus whatever. Now this isn't going to work because this is going to be a tuple. So let's go ahead and basically just convert it into a string. There are a million ways to do this. I'm just going to use the join Python method function to basically just convert it into a string. And then we then want to pick a number basically because the last number needs to exist. So I'm going to go ahead and basically just wrap this in a number around the for loop. So basically for number in range of whatever. So we'll just say, I don't know, 10. That will basically just do the number aspect, just so we have a little bit more flexibility, because the char set might not quite work, but that's okay. Fine, we'll go ahead and add in the number. Cool, and that should now maybe give us what we're after. Go ahead and just hit run. Okay, getting an error here, that's fine. That's because the number needs to be converted into here. Now we may not necessarily need this number here, but it just gives us the flexibility in case we can't quite reach this magic number with just the characters alone. Go ahead and hit run. Cool, we got a bunch of falses, but that's okay. We only care about if it's true. We can go ahead and just add an if loop here. So if it's true, we'll go ahead and then print basically G3 out. And then we don't need that. We can now go ahead and run. We're getting an unmatched thingy. That's because that's like that. Nope, that's fine. Go ahead and hit run, and then we should now get something. We didn't, so obviously mess something up. We'll go ahead and actually just print out this here. And I want to basically just have a look. So we're getting a bunch of numbers, but maybe we're just not getting a collision. Maybe if I make this number say 404, as I think I saw somewhere, yeah, 404 here, we should then get a collision. Okay, yeah, so now we're actually getting a collision. Basically, with the numbers and with the characters and the numbers we have, we can't get a combination that equaled the 346. So we made it 404, and that now works. So we have to basically find a number that's going to work with the current magic number. That's okay though, we can work through that. So if I go ahead and remove this here, go ahead and hit run, we now get basically 2 examples where this works. Just for the sake of covering all the possibilities, I'm going to go ahead and just make this a 0, just so we have an extra integer that we can use, because it may be useful. It hasn't made a difference. Okay, cool. So this should now work. We'll go ahead and copy this, and we'll now go ahead and put it into test. So that is now G3 complete. Sweet. Let's move on to G4. Taking a look at G4, it's just one line, and it just returns basically true if the values are correct. It looks a little bit daunting at first, but it's really quite simple when you figure out how to bypass it. Basically, what it's doing is there's a few bits going on. So in this zip part here, zip basically takes, so we'll take this here. Zip will take this bit here, and it will take the 0th index of the string, so this basically, and this, so this one, and then basically do an XOR on it. But the zip doesn't just XOR it, it actually will combine, say, the A here with the D there, so it's going to be like A, D, A, D, A, D, etc. Basically, it will just basically zip them together, like so. We don't need to worry about it too much. We just worry about obviously brute forcing it. So we need to go ahead and just adjust a few things. So we want to go ahead and basically just take this out of the way, and we're going to make this to be our 0th index. So this will just basically be what we took on here. So basically key 12. We'll go ahead and put that in there, and then this one will be whatever we want it to be. In our case, we'll call it G4, unless it's been taken already. Looks okay to me. And much like G1, where basically we had to use this brute force thing, we basically need it to equal this when it's been transformed. So we're going to use the same thing here. So I'm going to go ahead and take this basically, go into G4, go ahead and just paste it above. Okay, cool. I didn't quite get all I wanted there. I want the for loop as well. Cool. And now go ahead and paste that above. So now we can go ahead and just put that there, and now make this G4. So what this will now do basically is it will create a 3 character string, but that's not what I want. I want to go ahead and make it all the characters it needs to be, which is 5, because there's nothing complicated here. It's just taking the raw key bit and test if when we zip this and the value of this together, if we get this. It's going to be a little bit brute forcey, but it's very much possible. In order for this to work though, we'll go ahead and just take G4 and we'll just go ahead and overwrite it to be a list again. So G4 equals this dot join. I know there are a million ways to do this. I'm just doing it this way since I know what's going on under the hood. Cool. And then that should now be okay. We'll then go ahead and then do if, basically mean if this is true, then go ahead and print G4. We'll go ahead and I'll give that a run and see what happens. That didn't work, but maybe it's because I haven't quite matched the regex. So if I look in the regex here, we have a bunch of Ds, but actually it accepts numbers as well. So actually we need to go ahead and adjust this to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. We'll go ahead and run this again. And we got a value GAMD2. Cool. So that I'm happy with that. We'll go ahead and copy that and go ahead and put it in here. Basically, we have the 4th value, now we need the 5th one. So now G4 is done. We actually have a CS and not a G5. So this is a little bit different. This is like almost like a checksum. In this case, what it's doing basically is this is taking the very, very last segment. So basically this number here, this 4-digit number, and checking that the 4-digit number is equal to the value returned from here. So we'll go ahead and go to reference. And we can see here that we have a function, calccs, so calculate checksum basically. We'll go ahead and pop this into here. Now, this key split basically takes the very, very last value. It takes all the values other than the last one, so basically these 4 segments here, and goes ahead and checksums them. Quite simple. We don't need to do anything really for this one. But what we do need to do is we need to take that knowledge and incorporate that into what we already know, okay? So we know that basically we have this static, except this one isn't static. This GMD2 isn't static. Actually, I think it's GM3 isn't static, yeah. So G3 is actually not static since it uses the magic number, meaning we basically need to use a checksum along with the G3 to recreate it every time and basically brute force it. So what that means basically is we can't just create this from scratch and this will work once. We have to regenerate this third segment based on the magic key by basically brute forcing the magic keys, and then we'll then get a list of relevant numbers for each basically checksum, like a hash. So we'll go ahead and just have a demo for the moment as to how this should work, and then basically we can kind of work forward from there. So we'll go ahead and basically have we'll remove the self, like that. We'll go ahead and have the key is equal to this. This will basically just take the whole key minus the checksum, and then pass it into here. If we now go ahead and hit run, we'll now get a number 1312, right? If I now go ahead and basically take in all this value and replace it with where it was before. Yep, cool. Now run it. We'll now get a different value. 1355, okay? Sweet. So if we now go ahead and run it again, we should now get these numbers, right? Now, let's say that for some reason in our G3, the magic number is not 404, and it is indeed, I don't know, 450. We'll now go ahead and run it. We're now going to have a different value if it even gives us one, 400. Yeah, so it now going to give us a different value, like this one, for example. Now when we go ahead and pass it into the CS, like so, we're now going to get a different checksum, and then that's how it can obviously mess up. So we need to basically go ahead and incorporate the checksum aspect into our final code. We're going to go ahead and create a new file called final.py, and basically what it's going to need is it's going to need the code for G3. It's going to need the static G1, 2, and 4, and then it's going to need the checksum. Okay. And I'll also add in the checksum, not the checksum, I'll also add in the valid formatter as well. Basically just so I can check for sure that the format meets what it should meet. So here is basically just a bit of code that manages the if the regex matches. This will basically make sure that we only ever provide valid keys, okay? So we'll go ahead and basically just take the checksum, like so. So we have the checksum, like I say, just takes the key, splits it on this one, and then takes it. So the way I've written this one, I'm not going to take the final one because we don't know the checksum. So I'm going to go ahead and just take basically all of the values before the checksum and then return it. We then also need G3. Now G3 is what we had before, so we'll go ahead and basically just take G3, very simple. In our case, the magic number will need to be iterated over, so we'll go ahead and add that in there as well. Where's final? Dev G3. Cool. A few adjustments need to be made, of course, but that's okay. We'll go ahead and I did copy these in there, but apparently it hasn't copied right. Or have I messed something up? Somehow it hasn't. Oh, yeah, it has copied it, and it's just okay. I see what happened. Yeah, this is just off a little bit. Cool. We already have that one. Cool. Fix this. Cool, so that should now be okay. So what we'll go ahead and do is, just so we can see if it actually works, we'll go ahead and call G3, basically. We'll go ahead and hit run. And we get a bunch of values back. Let's go ahead and make this 404 again, just so we can get the one value back that worked. Cool. So that now gives us G3. Sweet. Now we don't actually know the magic number, so we're going to have to basically enumerate over that. So what I'll do is I'm going to go ahead and actually put this into a for loop. So we'll put magic number there. And then we'll go ahead and for loop it in our main function. So we'll go ahead and just create a very, very basic main function. So something like that. It doesn't actually have to be called main. I'm not going to call it main in this case. Basically, just iterate over the magic numbers. Now, the reason I'm using 300 to 600 is because the value of these can only be a certain number. So XP, for example, will have its equivalent decimal sum. This number will have its own decimal sum, and then the two values for 2 will have their own decimal sum. And I did the maths, and maybe I messed it up, but basically the smallest number it could be, I think, was 312. Although it's no big deal if I got that wrong, because basically I can just adjust this for loop, and it won't make a massive difference, really. Cool, so we want to go ahead and basically take the G3 is equal to this, basically. I'm going to call this seg3, just so I don't get any, like, confusion. basically go ahead and check if it's none, because basically if it returns a none, then it might not actually work. So we'll go ahead and just basically just check that it's returning a valid value. So basically something that isn't none. Then we can go ahead and then do this. So we can then go ahead and then take the key is equal to key 12, segment 3, which is this, gam_d2. We can then take the checksum, which will then basically just take all of these basically, do the checksum for it. And then the final key, like so, is basically just this plus the checksum. And then if it's valid, then print it basically. We'll go ahead and give that a run, and hopefully it gives us something back. Just check that I've got all these correctly. We'll see. Add in magic number as we missed it when we ran it. You need to go ahead now and go new terminal, go to -free code, group code. No, I believe it's just in group code, yep. And then it should just be called final, cool. And then we'll add that into codes.txt, code, cool. If we now cat code.txt, we'll now see all the codes. Cool. In order to do this, we need to go ahead and basically log out of the admin and into our account, so sub@Sakura. And we need to go ahead now and use Burp Suite's intruder to register the key. We'll go ahead and say put in a key 1. We'll go ahead and we have burp listening, proxy, intercept is off. Go ahead and add key. Cool, that's now in there. Right click, go to intruder. We'll go ahead and now go into clear. Now, I did this before and basically there's a little bit of rate limiting going on. So I'm going to go ahead and add in basically just a little bit of slowing in there. So basically we'll have the maximum concurrent requests to be, say, 1. The delay between requests to be, I don't know, 10 milliseconds. And that will just basically reduce the likeliness of us getting kicked off. Go ahead over to my home, Kali, wherever it is, HackTheBox, and then it should be early access, cool, and then code.txt, cool, and now it should be okay. We have 58 codes there. I'll take that. Yeah, we'll go ahead and hit run and just see what we get back. Interesting, actually, you need to go ahead and just cancel this and go ahead and add in the redirect, because basically the redirect is not enabled. We'll basically just watch this go through. So this is our baseline request, basically the very, very first request we made using like the word key. And then I'll unpause the video when we get to the final bit. Here we have a request 12890. We scroll down, game key successfully added to your account. Have fun playing. Sweet, so that's worked basically. We just took the game key that we generated, and then now we have this in here, and then now we're being added to it. Cool. So now go ahead and hit refresh. Go ahead and turn Burp Suite off real quick. And now we have a game. And now we can log in here to game. And boom, now we can log in. Sweet. So now we're in game. Okay. Now, if you remember from before in the forum, there was reference to a scoreboard showing errors. Now if we look here, there's a scoreboard. Cool, I found a critical bug in the game scoreboard. My username returns strange errors on the dashboard. Please fix this issue. Thanks, single quote man. Cool, so if we go ahead now and play this game real quick. However you play it, no idea. Now go to scoreboard, we have a MySQL error. Now the reason we have a MySQL error is because my actual username is using single ticks, and it has broke some stuff. But basically, this is some second order SQL injection. Now, second order SQL injection basically is where your stored input, example, my name, is in the database, and then that data has then been used in a subsequent request via SQL or some other, and then that has then caused an error. So second order SQL injection. We'll now go ahead over to our profile and modify our name. Let's go ahead and just make it say test, right? Just something very basic, test. We'll now go ahead and hit refresh. And that says our name. To make this a little bit easier, I'm going to go ahead and just split these into this. So I'll put this over here, like so. I'll go ahead and put this over here so we can see a little bit easier. Cool. I'm going to go ahead and remove this. So now if we go ahead and change this to be, say, test with a single tick, When I go to here, we have an error. Okay, so basically what it means is we have SQL injection to some degree. Now, how do we escalate further than this? Well, I messed around with it for a little while, and basically there's a few things that we can do. For example, I can say do all 1 equals 1, like so, and that kind of works, but kind of doesn't work. Now, if I go ahead and then comment the rest out using the --+ we then get all the users back. We have Chronos, Farbs, Firefart, and obviously myself. So we do have SQL injection. How do we get further than that, though? Well, after some messing around, I figured out that basically we can use union injection to basically dump the database with some fancy little tactics using the SQL error that we got. So let's go ahead and cause another error. And let's just go ahead and review the SQL error, right? So go ahead and hit save, go ahead and hit refresh. So look, so we have here right syntax near test close bracket. Okay. What that tells me basically is that we have a close bracket in the request. So in order for us to do additional stuff, we need to close off the query and then run more stuff. So let's go ahead and close the query off here, right? And then we'll go ahead and say do union or like order by one dot space hyphen. What this will basically do is it will create a comment at the end of the request. Go ahead and hit save. Now this might not work first time, it may work, okay? No error, that's good. We'll go ahead and make this 100. Hit save. And we get an error. Column not found, 1054 no column. Basically means that there's at least one column. Let's go ahead and add in 2. Okay, no error, that means there's at least 2 columns. Go ahead and add in 3. Okay, no error, that's good, cool. Go ahead and add in 4. And we get an error. That tells us there's 4 columns. Okay, so 4 columns, that's fine. We'll go ahead and add in here. So I'll go ahead and say 3 cols, just in my notes here, 3 columns. Now we can go ahead and modify this to be a union injection. So union select null, null, and null. The reason we use null basically is because this data type won't throw errors if it's, we'll try to put an integer in a string or a string in an integer. No errors there. Let's go ahead and put a 1 in here. And we get 1 coming back. Okay, let's go ahead and change this 1 to be, say, database. It might be a case where it will allow us to use strings. Maybe there'll be an error, we'll find out. Okay, yeah, so the database is called DB. Cool. Go ahead and say user. And it gives us the user we're running as. It looks like we are running, interestingly, well, it's like a Docker container because we're using the 172 IP scheme. And this host is called 1010 or so. So it really looks like a potential Docker running. Let's now try and escalate to try and get actual data from the database. I'm going to make this full screen so you can see a little bit easier. I'm going to go ahead and change this to be table name because I want basically to see all the table names, table name. And then we want to go ahead and then say from, I'm just going to go ahead and copy because it's just a little bit easier and rather than messing it up. Basically from information underscore schema.tables, basically this table here hosts all the SQL information, and then we're using the .tables to basically give us all the tables, and we'll be using the table name to give us the table names. Go ahead and do this. Now we'll go ahead and refresh, and we have all the table names. We have a users table, that's what I'm interested in. So that's fine. We'll go ahead and make this bigger. We'll go ahead and change this from table name to column name, like so. Go ahead and I'll change this from to columns. Columns where table name equals users. That might work, I might have messed it up, we'll find out. Okay, there's an error. Unknown column users in where clause. That's okay, probably messed something up there. Union select column name, null from information schema.columns where table name equals users. Okay, interesting. Maybe the reason this didn't work is because we didn't quote the use of the word users. Go ahead and hit save. Go ahead and now undo this. Go ahead and hit refresh. And boom, we have email, ID, key, name, and password. We'll go ahead and basically pull these down. Calls, cool. So I don't care about, say, the created app, but I care about the other ones. So we'll go ahead and basically scrap the majority of this and change this from there to be from users. Like so. We'll go ahead and change column name to be, say, name, and then we can change this to be, say, password. Go ahead and hit save. Go ahead and hit refresh. And now we have the admin and that kind of thing. Let's go ahead and take this admin hash. Go ahead and hit paste. And we have a result here for best SHA-1 hash encryptor. We have game over. Cool. So basically, we have the game over password. Now we could go ahead and do this for the rest of them, but in the mind of time, I'm going to go ahead and just move on. So now we have game over. Okay, so now we have that. Let's go ahead and take this further. Go ahead and close that. Cool. Let's go ahead and now log over to here, the dev.earlyaccess, and use game over. And boom, we are logged in. Sweet. And we look like we have some kind of functionality, file tools, and hashing tools. Interesting. So if we go ahead and go to inspect element and go to network, and we now go ahead over to hashing tools, and we now go ahead and put something in here, go ahead and hit hash, we'll see that we're making a request to hash.php, which is found in actions/hash.php. So when I saw this, I was like, okay, interesting. We have hash.php. Then I went over to file tools and said that it's still in development, UI not implemented yet. But it says UI not implemented, but it doesn't say the functionality isn't implemented yet. So what I did is I simply just went to where I was with the hash before, go ahead and hit hash, copy the URL like so. And I was like, okay, so this is called hash. And then I tried file, and we got an error saying, please specify file. If I go ahead and say files, we get not found. So that basically tells me that we have a valid PHP file. I messed around with trying to get the file name to work. So for example, file equals a, that didn't work. So I decided to use basically this list here of parameter names and use it via burp. Go ahead and copy this list of parameter names just to my clipboard for a second. We'll go ahead and turn intercept on. Intercept is off right now. Go ahead and hit enter. Intercept intruder. Go to intruder. Go to clear. Wrap this in that. Add. Go to options. Payloads. Go to paste. And then go ahead and just hit start attack. And basically just wait for some results to appear. This didn't work as I didn't add the equals on there, so it didn't actually validate it as a valid argument. So we go ahead and just switch this around. So file should be there, and then equals, we'll just do A. Okay, we'll go ahead and start attack again. Basically, I just messed up my intruder, is all. Wait for a valid response to come in. We have a 54 there for file path, and we got a invalid file path. So we'll go ahead and copy this, go to repeater. Now if we go ahead and hit enter here, we get an invalid file path versus the previous error we had. We'll try /etc password. For security reasons, reading outside the current directory is prohibited. Interesting. So basically what that means is we have got some kind of file read, but that's it. If we now go to say hash.php, which is what we previously were using, it kind of executes it and we're getting some errors here. We go to file.php. We're getting a file execute successfully. So I spent a little bit on this, basically trying to figure out what to do. In the end, I realized, oh, we could probably just use PHP filters, since this is a PHP app, to read the contents of the files. I decided to use this to read the hash file, which then gave me effectively a base64 equivalent of the hash PHP code. We'll go ahead and copy that, go ahead over to decoder, paste it in here, decode as base64, and now we have the PHP code. Now go into control new, go to save, hash.php, and boom. Let's now take a read of the code. So PHP code it has a lot of little quirks as to how it's put together, and that can be a problem in lots of cases, but we'll read through the code bit by bit and basically see where it takes us. So it's saying here that if action is set, then let us into the next if loop. Then it says if action is verify, then do this. Else if the action is this or that, do this, do that. Now what caught my attention was the use of this hash password function that is defined. Now if we look over here, we have a hash password. It's actually referred to here and a little bit further down here. Now if we see here, it says if debug is set, basically if it's not set, throw an error, but if it is set, then it will then run this. So it's here, request hash function and request password. Now, if we look here, we have control over the hash function and the hash password. You can see here, request hash function, request password. there's passed in here. So this is hash function, this is hash password. Now, it's kind of hard to see, but basically what we can do here is we can actually control this here. And what this will do basically is this will give us the ability to control the function that is used. And PHP has got inbuilt functions to, say, run a shell. Let's go ahead and try this out locally and see what happens, right? Okay. So if I go ahead and create a new one, we'll call it, I don't know, shell.php. Go ahead and hit this, right? Go ahead and just wrap it in the PHP file descriptors. Cool. Now, if we go ahead and then call hash password, so hash password, like so, and then we then go ahead and say do shell exec, like so, and then we'll go ahead and say do like, I don't know, touch pwn 1337, okay? And then we then run that. We'll go ahead and open up a terminal. We'll now do ls pwn 1337. We don't get anything, doesn't come back, right? If we now do php shell.php. Don't know why that printed it out, but it's okay. If we now do ls, still hasn't created it. Maybe we messed something up. Add the semicolon there. Maybe that's why it wasn't working. Go ahead and restart again. Not that one. Go ahead and see if it's now created it. It hasn't. I know why this isn't working. I haven't used the proper PHP descriptors. Cool. If we now run that will now work in a second. And I'll go ahead and run this. And boom, ls, and then now we have the new file created. Sometimes it helps to read your actual code. So that has now created a file, basically. We can use the same logic to basically create a reverse shell. Let's go ahead and try this as for a proof of concept, right? We'll go ahead and now do, go ahead and just close out of the way. We'll go ahead and just clean it all away. Now do shells 1338, which will basically open up a listener. And then what we'll do is we'll then take, say, this bit of code here. And then we'll then, actually, I want to make it a little bit more crisp. So actually, we'll do something slightly different. We'll do lweb, basically to listen, where we are. I'm going to go ahead and do nano s for a shell. Go ahead and paste in the shell. Cool. Now we'll then do web, and then we'll then do, in our shellcode, we'll now change this to be curl 10, 10, 14, 3, colon, 9000 s -s, pipe into bash, right, okay? Then when we run this, what will happen, basically, is we should then get a reverse shell, locally, that is. PHP, shell.php, and boom, we had a connection here. Our shell did die here, but that's okay. As actually, it didn't die, it's actually just our prompt. It's just basically looks like it died, but it didn't. If I now do exit, we now get dropped to our original shell. That's now working. So let's go ahead and then use the same logic to now get a reverse shell on the remote machine. Let's go ahead now and kill our burp. We'll go over to hash, wherever it is. We'll go ahead and actually, because I already have this here, I'm going to go ahead and just right click it, good copy, as kill. But there are many ways to do this. I'm just using it this way. Go ahead and put the reverse shell there. We'll go ahead and run the kill here. Actually, I think it was web was here. And then we'll go ahead and then just push this up here. Do the kill here. And then we'll go ahead and basically adjust the password to be our reverse shell code. For example, this kill, that, cool. Go ahead and paste that in there, so that will then run that code, and then the hash function needs to be the actual function we want to run. So shell exec, hit enter. Did it work? We didn't get a request, so maybe it's a little bit off. That's okay, let's keep messing with it. Let's just check that it's worked. Actually, the reason it didn't work is because we didn't add the debug parameter. So previously, the debug parameter, we need it in order to do things. We need the debug parameter. Let's go ahead and add that in there. So, and debug equals what? Go ahead and hit enter. We have a request made to our web server, and we have a reverse shell retrieved. ID, www data, hostname. web server. Sweet. We'll go ahead and just minimize these out of the way because we don't need them right now. Cool. Alrighty, so we're now using this user. Let's go ahead and just see what's in the home directory, right? Home, www-adm, interesting, cat. That's the password. Basically, we want to see what users are on the machine. Actually, I'll just grab everything. And we have a home www with a bin bash. Interesting. So I originally overlooked this, but basically what we can do is we can suit that user, so su www-admin, and then password of game over, the previous password of the user, and then now we can become that user ID, and then we're now www-admin. We'll go ahead and just take this Python upgrade shell code here, hit enter, and now we have an upgraded shell. Sweet. So the first thing I tend to do whenever I get access to a box is first of all to see what directory I'm in, and basically just traverse out of there. So just basically see if there's anything interesting in here. Go ahead and just CD back a little bit, just to see what's in here. We have a game. Can we go into game? There is some stuff in here, leaderboard, score. That seems to be where we got the shell in the first place, ls. CD, ls again. CD, HTML. Interesting. We'll come back to that later if we need to. Go ahead and CD into back a little bit more, var. Okay, cool. CD into our home now. And there's nothing in here, but if you do ls-la, we see there's a wgetrc file with a recentish timestamp. Cool. If we look at the wgetrc file, cat wgetrc, we can see here there's user API password, secure API password. Now, if we refer back to where we were before, so I'm actually going to go ahead and just copy these real quick to my notes. Go ahead and copy, go ahead and open up mousepad just to put these in here. Cool. If we CD back to where we were before, CD, I think it's HTML, CD www. We go into the HTML directory. We'll see there's a few bits and pieces in here. If we look into app, we can actually see, we go ahead and grep for API. We see there's actually a models API.php, HTTP get HTTP API colon 5000 verify. Cool. So if I then go ahead and say curl that, we get basically an error. But if we go ahead and remove the verify, we get welcome to the game verification API. You can verify the keys via here, here, and here. Now, if I go over to this checkdb, we basically get an invalid HTTP authentication. Now, what we can do is we can actually go back to where we were before, so CD into the home. We can now use the wget file that we had previously, and wgetrc will basically just use this file. If we can now go ahead and wget it, like so, and then we go ahead and go cat check db. See, notice this time we didn't get an authentication error, and boom, that has worked. We'll go ahead and copy this. Now, you can just pop this into VS Code or whatever, but I find that a little bit ugly. I'm going to go ahead and just nano it and be like, we'll just call it, I don't know, JSON. Paste this in here. And then we can then use JQ to basically just view it. So JQ sudo apt install JQ. Nope. Yes. I did it in VS Code the first time, so I don't have a JQ installed. Use JQ. Call JQ, and then I believe it should be. I think that is the syntax, if I recall correctly. And then JSON. Yeah, cool. So now we can view the JSON basically. So if we look through here, basically what we can see is there's a few passwordy bits in here. There's quite a bit to it. If we just keep scrolling through, we'll find that there is some passwords. So that's from the top. We'll go ahead now and just scroll through, try and find, there should be a password in here somewhere. We'll go ahead and actually just grep for it. Maybe I need to add in -i to make it case intensive. Here we go. So we have a MySQL password of true and a password of this. Cool. Let's go ahead and basically take this and we'll store this in our mousepad. That's not what I wanted. It's not even what I grabbed. Copy, mousepad, paste. Cool. We'll now go ahead and just trim it a little bit. like so. That should be okay. Cool. Sweet. So let's now go ahead and do SSH Drew at box, drop in the password, and boom, we now have access to Drew. Sweet. We notice when we get access to the box, we have a mail. I'm going to go ahead and cat at C mail, I think it is in. Nope, I think it's in var mail, actually, my bad. Cool. Drew. Okay, let's go ahead and read this. So, to Drew at Early Access from game.adm, game.adm earlyaccess.htb. Hi Drew, thanks again for taking the time to test the we received feedback and implemented a health check that will automatically restart the game server if it has crashed. Sorry if the current instability of the game, we are working on it. If the game hangs now, the server will restart and be available again after about a minute. If you find any other problems, please don't hesitate to report them. Thank you for your efforts, yada yada yada. Cool. So, basically, what it tells us basically is that they've implemented some functionality to restart the game if it crashes, okay? Now, because this box is called Early Access, and it's related to games and stuff, it seems very likely that that is the next part of it, and the mail is a nice direction in that sense. Cool. So we'll go ahead and hit ls since we're in here. We have the user.txt. Go ahead and hit ls-la, and to see what's in here. We have an SSH folder here. Let's go ahead and cd into SSH. And we notice there's some ID RSA keys. Interesting. I'm going to go ahead and cat the ID RSA.pub. And we can see here we have a game tester at game server. Okay, interesting. Can I ping a game server? Let's find out. Ping game server? No, nothing's coming back. Okay, fine. So let's go ahead and, with that knowledge, let's go ahead and see how do we talk to game server. So we do IP-ADD. We can see here, basically we have some of our interfaces, right? So we have 172 host, 172.19 host, and 118 host. And if we look at ourselves, IP-ADD, we have, we're running at this one. So Docker 0, 17.01, I believe it was at least. Last time I checked when we did the MySQL before. The SQL injection, I mean. So based on that, let's go ahead and basically just try and SSH to these. So SSH, I think it was game tester at, let's take this one. And then we'll then use -i, ID, RSA, connection refused. Okay. Next one, 1904. Okay, cool. And we logged in. Sweet. So what tells us basically we now have access to the game server. Sweet. So, where do we go from here? Well, if we look into the local directory where we spawn, there's nothing much in here. If we look into where are we right now? When game test, if we look into the root, we have a ls-la. We have docker entry point.d. Okay, interesting. And then entry point.sh. Cool. Let's go ahead and cat entry point.sh. For EP in docker entry point.d, do this echo running. So it seems to run some kind of file. Now, when I initially did this box, I didn't understand what this meant. However, if you look into the SSH of Drew, which I have lost the password to, you will notice actually that there is a shared directory in this. I probably should have shown this. This was in my Linenum script, but basically there is a docker entry point.d with a Node.js server in there, and then if you look in here, there is also a docker entry point.d. And the fact this is blue, which is what led me to it, basically means it's shared to the best of my knowledge. So basically, if I go ahead and were to cd into docker entry point.d, you'll see in here that there is a node server.sh. If I now go ahead and touch A, I don't have permission. If I now go ahead and cd into opt docker entry point.d, cd, and I now do touch A, I can write a file, but this cannot write a file. So I messed around with this a little bit, and I found that basically the solution to the next step is to look into, let me go ahead and cat the Node.js server. You can see here that there is a server.js. Now, this is part of this machine, this is part of this Docker instance and not the Drew instance. Then I'll go to find/name server.js. We see here there's a user source app server.js. Go ahead and cat it. Sweet. Okay, so we have some output here. We have the permission to read the file. I'm not quite happy reading this in the terminal, so I'm going to go ahead and take it out, basically, and just pop it into VS Code. Cool. Go ahead over to here. Server.js. Cool. Hit save. Fine. Sweet. So let's go ahead and read the code, basically. So this is some JavaScript, basically. Some Node, some Node.js. And basically what it's doing is we have a few variables set here. And if we think back to previously, when we looked at our mail, so cat @c cat var mail true. Basically, the team said that if the server crashes, it will then reboot. Basically, so if we look into here, we're basically looking for a way to crash the server. Now, ways we can crash the server are user input that we can provide to it. In this case, we have an if function, an if statement here saying if basically the number of rounds that you sent as user input in the request.body parameter is not a number, throw an error. Okay. On the autoplay endpoint running on port 99,000, so 9,999. So if we now go ahead and just see, can we even talk to our host? Because maybe we can't. Curl, I think it was 17. IPN. It was curl 172.19.04. That doesn't work. 9999, and we get some HTML back. Sweet. So that's kind of working. Let's now go ahead and add in some data. So, for example, in our case, round. I think it was round or rounds with an S. Rounds. Let's go ahead and check actually. Rounds, yeah, with an S. Rounds equal 2. We got an error. Interesting. That is because we haven't added in the autoplay endpoint here. Go ahead and hit enter. Starting autoplay with 2 rounds. Basically, it's taken 2 rounds from us. Interesting. Cool. Let's go ahead and hit ls here. Seems okay. Let's go ahead and now put in something that isn't a number. We could say do minus or something. I'm going to go ahead and make it a float. So basically like 2.1, because 2.1 is not a number, it is a float. So therefore that might cause something. Now, when I was originally on this, I realized that when I broke the server, my SSH stopped working because I guess this Docker instance would reboot. In addition, you can also see here that this hasn't come back to us, meaning that something's gone off. Give it a second, hopefully it will then die. We can see here that basically the connection to the Docker host died, and now we have to SSH back in again. So, what do we do here? Well, what I noticed basically when we get back into the server in a second, when it boots back up, is if we refer to that Docker sh file, basically executes those, which means it executes the node server starter file. That will make more sense when we get into the box when it comes back. And basically what that means, since we have access to write to that file, we can then execute potentially our own code in that file, and then obviously escalate to the next level. So this should now be online. It's taking a second. For some reason, the .4 host wasn't working, so I just did IPN and used the 1903 host, and that seems to be working okay. So basically, if we go ahead into our root and go ahead and ls, and we go ahead and cat the ngpoint.sh, that will hopefully make more sense now. Basically, when the server dies, this gets run, and basically what it means is it will then execute whatever files are inside of this directory, and we have access to write to this directory. So if we can go ahead and create a file, like if we can go ahead and create, say, a bash file that will do something, then we move to go ahead and escalate to the next level of access. Now, this is run as root. So if we go ahead and ls-la, we should see that this is run as root. So entry.sh is run as root. So basically, because root is running it, it means that if root then runs it in, then it will then be executed as root, and therefore if we can get a reverse shell, we can then of course become root. I'm going to go ahead and just try something. So if I now do ls, the A file is still there, but it does commonly get deleted, as I found. So what I would do is I'm actually going to go ahead and make my life a little bit easier and actually create a basic file just to do some of the work for me. So we'll go ahead and basically echo some content to a file. Let's go ahead and echo, say, touch /tmp, if I can spell right, sub to then it needs to be, we'll just call it, I don't know, sub.sh, and then we need to go ahead and chmod plus exit, so sub.sh, and then we can then curl it. Cool. Now go ahead and enter. That's now running. Now, as of current, if we do ls temp, nothing is in there, but give it a minute or so and we'll see. We can see here the server crashed. Let's go ahead and log back in again. Go ahead ls/temp, and boom, there is sub. So it has created a file. We now do ls-la. Sub is actually owned. ls/temp-la. We now see that sub is owned by root. Meaning, if we can then get some reverse shellcode in there, we can then, of course, try and get root. So that's what I'm going to go ahead and do. So I'm going to go ahead and then right-click here, go to horizontally. We'll go to shells 1339. We'll go ahead and take, say, this very, very top one. Like so, copy. Now we'll run the same thing, except this time we'll go ahead and replace this touch code with a reverse shell. Looks good to me. We'll go ahead and run that through. We'll go ahead and just wait here. Go ahead. So here we're getting an error. That's because we got no root to host. Just modify this to be 3. Go ahead and hit enter. Keep an eye on down here for the reverse shell to come through. Now, while that's running, it's worth noting that basically in this directory, in the root, we have docker entry.point.d, and we can't currently write to this directory. This user can write to this directory, but not as root, just as the Drew user. If we can get a root shell, as we have here, on the, so if I do hostname, we are running as game server, and hostname here, we're running as early access as Drew. Actually, let me SSH into here. Now if I do hostname, we can then see we're running as game server. Now I have root access into the server. I can then do, say, I don't know, cat etc shadow if there is one. Yeah. So based off that, we can now use basically a vulnerability in the way that it's not so much a vulnerability, but just the way that basically what we can do is, because we have root access to a shared folder, we can write to a host folder. So this Drew has got this folder here, docker entry.point.d, which is on the host machine, that the game server can also access. We go over to docker entry.point.d, we can also access that, but the root can actually write to it. So if we now go ahead and say cp bid like sh, for example, since bash will throw an issue just due to architecture differences to docker entry point. So this isn't going to work because I don't have autofill, but we'll go ahead and just do this manually. cp that into there. Now we cd into here, cd into docker entry.point.d. Go ahead and ls. Now the sh's are there. We'll then do chmod plus s. Although before we do, let's go see what we have the sh's in there. I do chmod sh plus h. That will then give it root permissions. You can see now it's red, ls-la. It's now owned by root via the Docker container. And then we can then do /sh, enter. We run ID, and we are running as effective ID of root. And then we can do cat root.txt, and boom, the box is rooted. So hopefully that was helpful. We got the root in the end. Apologies for my illness and my garbling of talk. It's just I need to get the video out, so of course I needed to just push through. Hopefully you learned something. If you did, like, comment, subscribe. And as always, I'll see you in the next one. Take care, everyone. Bye.